Assalamualaikum warahmatullahi wabarakatuh. We will explain about lab 4, Infinite Impulse Response, FIR Filter Design. My lab partner is Azimah binti Zainal Abidin and me, Aliza binti Mazam. First, we go to the procedure. Okay, for the procedure, we have to do the system impulse response for the vector for H1, H2, H3 and 4. And then we have to do the frequency response. We have to subplot the frequency response, and then we have to plot the z-plane and z-plane for the 0 and pole. Okay, for the H1 here, there is 4 values, 0.1, 0.4, 0.4 and 0.1. So we input the n is 1024, and then we input the value here on the impulse response vector for the system on the HFIR. And then we have to subplot the frequency response, magnetic response for the impulse response, and then the label for the x label is normalized frequency, and then the y label is the HFIR, and then the title is magnetic response. And then for the B, and then we have to do the plot for the z plane. So here we have to subplot 4 to 2, and then the title is z plane plot H1. For the H2, we have to input the same n, and then we have to input the value that is given on the question, where 1, 0, negative 1.6180 and 0 and 1.1680, 0 and negative 1. This is the value for the impulse response. And then we have to do the same with the H1, where we have to subplot the frequency response, and then the same value here we have to subplot for the z plane for the 0 and the pole. And then for the C we have five value, so we input the 5 value on the impulse response on this line 49, and then the value we input here, and then we have to do the same with the H1 and H2, where we have to subplot the frequency response. And then from the same value we have to subplot for the z plane for the 0 and the pole. And then this for the sixth graph. And then for the last one we will have to do the same for the H1, H2 and H3 and H3, where we input the data that given to the HFIR for the value impulse response here on the line 72. And then we have to do the same, which we have to plot the frequency response, and then the z plane for the 0 and the pole. So we run the coding. Okay. Okay, as we run the coding here, we get that for the system 1, this is the magnetic response for the system 1, and then this is the magnetic response for the system 2. And then for the system 3, this is the magnetic response, and then for the system 4, this is the magnetic response. And then on the right side, it shows the z plane for the all system. For this is for the system 1, system 2, system 3 and system 4. And on the z plane we know the 0 and the pole for the z plane plot for the all the system. Okay, that's all for us. For me, I will pass to Azimah.
Okay, thank you to Nak Aliza. Okay, so for my part, which is simulating. Okay, for C, we need to implement all the filter above for H1, H2, H3 and H4 in Simulink, making use of the common blocks such as unit delay, D is a unit delay, gain, D is a gain, and adder. Next, we need to generate two sine signal using sine wave block and observe the input and output signal using scope and spectrum analyzer. Okay, so this is an example for H1. Okay, we go to the Simulink. Okay, this is a Simulink for H1. So we run the Simulink and get the spectrum analyzer for 1. And this is a spectrum analyzer number 2. Okay, next we go to the scope. This is output for scope we get, which is magnitude square versus time. Okay, next we go scope number 2. This is output we get. Okay, sorry. Before that, we need to setting the Simulink sine wave setting. So we setting as lab sheet in the lab sheet. So this is setting for unit delay and gain setting. Okay, this is a simulation setting. Okay, as you can see here, this is H1. So the H1 analyzer, spectrum analyzer before FIR filter, and this is analyzer after FIR filter. So this is a scope for H1 and H2. Okay, next for Simulink H2. So we need change at the gain and add some unit delay and adder. So we run the Simulink. So the output we get for spectrum analyzer H2, graph spectrum analyzer before FIR filter. So we get this output. And this is output for graph spectrum analyzer after FIR filter. Okay, next for output scope H2, this is output for scope 1, and this is output for scope 2. Okay, next we go to the Simulink H3. So this is a Simulink for H3. We change at the gain as the value given in the lab sheet. So we run the Simulink. Okay, this is output for graph of spectrum analyzer before FIR filter. This is spectrum analyzer 2, graph of spectrum analyzer after FIR filter. Okay, next scope. This is we get output for scope H3 for scope 1, and this is scope number 2. Okay, next we go to H4 Simulink. Also we change at the gain the value and run the Simulink. As you can see, this is a spectrum analyzer H4, graph spectrum before FIR filter, and this is a spectrum analyzer after FIR filter. So for scope H4, this is output for scope 1, and this is scope number 2. Okay, for discussion, during the lab, we need to find the frequency of response of FIR by using coding given in the appendix. Thus, we should be able to get four types of graph of frequency response FIR filter and get the Z-plane plot graph. From the system given, we need to produce schematic diagram to observe each initial and final waveform. There will be a different initial and final waveform from the spectrum analyzer and scope. The difference is Simulink model will produce a discrete signal waveform while the MATLAB produce a continuous waveform. The outcome of the spectrum analyzer tool will identify the type of the filter being implemented in the system. The output signal after passing through the filter can be observed from the second scope. So this is our conclusion. At the end of the lab season, the basic concept and working principle of the FIR and IIR filter were understood. Next, the structure of the FIR filter we understood. In addition, the concept of certain basic FIR and IIR filter design technique were understood. Lastly, the capability of designing FIR and IIR filter to meet certain filtering requirements were accurate. So that's all from us. Thank you.